Mr. Latines from CITA section 22951A 3323. My selected topic is comparison between open and closed loop battery charging technique for lithium ion battery in engineering chemistry. Okay, now we see our agenda. What is battery? Second one, how many types of batteries are there? Third one, what is primary battery? Fourth one, what is secondary battery? Fifth one, what is lithium ion battery? Sixth one, what is open loop battery charging for technique for lithium battery? Seventh one, what is closed loop battery charging technique for lithium ion battery? Eighth one, comparison between open and closed loop charging technique for lithium ion battery. Now we see the last one is a conclusion. Now we see what is battery. An electric battery is a source of electric power consisting of one or more chemical cells with an external connection for powering electrical device. When a battery is supplying power, its positive terminal is the cathode and its negative terminal is the anode. The terminal marked negative is the source of electrons that will flow through the external electric circuit to the positive terminal. When a battery is connected to a external electric load, where redox reaction converts high energy reactants to a low energy product, and the free energy difference is delivered to external circuit as electrical energy. Historically, the terms of battery specifically referred to a device composed of multiple cells. However, the usage has evolved to include devices composed of single cell. Okay. Now we see how many types of batteries are there. Mainly, batteries are classified into two types. One is primary and another one is secondary. Let's see primary battery. It is irreversible. It is a dry cell. Here we can see this picture is related to primary cell. Okay, now we see the secondary battery. It is secondary batteries. It is reversible. Example, lead acid storage cell and lithium ion battery. What is primary cell? A primary battery or a primary cell is a battery, a galvanic cell that is designed to be used once and discharged and not recharged with electricity and reused like a secondary cell. In general, the electrochemical reaction occurred in the cell is not reversible, rendering the cell unrecharged. As a primary cell is used, chemical reaction in battery use up the chemical that generate power. When they are done or gone, the battery stops producing electricity. Now we see the secondary cell. A rechargeable battery, storage battery or secondary cell is a type of electrical battery which can be charged, discharged into a load and recharged many times as opposed to a disposal or primary battery which is supplied fully charged and discharged after use. It composed of one or more electrochemical cells. The term accumulates is used as accumulates and stores the energy through a reversible electrochemical reaction. This is information about primary cell and secondary cell. Now we see what is lithium ion battery. Lithium ion battery or lithium ion is a type of rechargeable battery which is used the reversible reduction of lithium ion to store energy. It is predominant battery type used in portable consumer electronics and electric vehicles. It is also sees significance used for grid scales energy stored and military and aerospace applications. Compared to other rechargeable battery technologies, lithium ion batteries have high energy densities, low self-discharge and no memory effect. Chemistry performance, costs and safety characteristics vary across types of lithium ion battery. Most commercial lithium ion cells used in intercalation compounds as the active materials. The anode or negative electrodes is usually graphite, although silicon carbon is also being increasingly used. Cells can be manufactured to prioritize either energy or power density. What is open loop battery charging technique for lithium ion battery? Open loop charging technique like pulse charging, constant current C and constant voltage CC and CV. The multi-stage charging etc. uses fixed battery parameter to decide the battery charging current. Effect of temperature varies during charging is generally not taken into account. In the case of open loop charging techniques, the temperature must be kept in certain range to enhance the effective battery lifetime. Charging current in closed loop technique depends on the temperature feedback. CC constant current and CV is a constant voltage. What is closed loop charging technique for lithium ion battery? Temperature plays a very crucial part in charging batteries and analyzes their performance. The block diagram of closed loop charging technique for lithium ion battery is shown in fig 1. In this technique, the charging current magnitude varies according to the battery voltage and temperature varies while maintaining the battery temperature rise in the specific limit. The temperature error is minimized using PID controller. PID controller outputs the current control signals. This current is further coupled with feed forward current FFC, which falls from 2 Celsius rate to 1 Celsius exponential. A high charging current is initially injected while temperature is kept within the maximum defined boundary, and the current drops exponentially up to constant temperature CT. When the battery voltage recharged to nominal battery voltage, battery is charging switched to constant voltage charging. This is about a closed loop charging technique for lithium ion battery. This is a fig 1 of CT and CV of closed loop charging technique. Here we can see the PID controller and power source and lithium battery and temperature sensing. Now we see the comparison between open and closed loop battery charging technique for lithium ion battery. Comparison between open loop CC and CV and closed loop CT and CV charging techniques is carried out for three different batteries initial SOC level, i.e. 0%, 20% and 50% respectively. Both conventional CC and CV are closed loop CT and CV techniques are simulated for complete charging cycle. Battery taken is 3.7 volts with rated capacity of 2.3 amperes with a nominal voltage of 3.2 voltage. Simulation results for battery initial SOC level 0%. Fig 3 and Fig 4 shows the input voltage and current given to a lithium battery. In CC and CV and CT and CV technique respectively, feed forward current for CT CV technique is shown in fig 5. Input voltage in CC and CV techniques 3.7 V and input current in 2.3 amperes. While the case of CT and CV techniques, the input current is variable, depends on sum of feed forward current and PID current, but voltage same as 3.7 voltage. Here you can see fig 3 input supply voltage initial 0. SOC level. Fig 3 and fig 4 indicates the initial same input supply current. Fig 3 indicates initial supply voltage and fig 4 indicates initial support current and fig 5 indicates feed forward current FFC initial 0% SOC level. These three are graphs. Now conclusion. This work presents a comparison between temperature feedback and based CT and CV battery charging technique with open loop CC and CV charging techniques for lithium ion battery. Modeling and simulation is carried out in MATLAB. Simulink comparison is carried out considering three different initial SOC level 0% and 20% and 30%. Simulation results of temperature feedback based closed loop CT and CV charging technique is compared with open loop conversion CC and CV method for initial 0% battery SOC level battery charging time with CC and CV. Technique is 60.38 minutes, whereas with CT and CV technique 45.63 minutes. Here we can clearly see the time varying. It shows that CT and CV technique charging time of battery can be reduced approximately 24%, 0.42%, keeping the battery temperature rise with predetermined limits. Similarly, result obtained for other battery initial SOC level, keeping temperature rises permitted level while charging improves the battery life. Further, faster charging may be achieved by raising the battery temperature limit with compromising the battery cycle and life. Here we see the comparison of open closed loop batteries charging technique in lithium ion batteries. Okay. Thank you. Have a nice day.